Just to introduce myself quickly, I'm Carlotta Dotto. I'm a senior data journalist at First Draft, which means that I use data, numbers, and data visualization to investigate this information. At least I try to investigate this information online across different platforms and online spaces. So I'm just going to go through a very quick outline of what we're going to cover in this training. I will kick off by introducing the topic of data visualization and how it became so relevant recently, reason why we have to be extra careful of what we put on our graphics because they can be very misleading, as we all know very well. So in the first part, I'm just going to go through some of the main reasons why data visualization can go wrong, providing some examples as evidence. Secondly, I'm going to go through some of the essential steps of dealing with the data to make sure not to produce those misleading graphs. And finally, we're going to move on to the more practical technical aspect, and I will give you a very short live demonstration on how to use one of the online library, which is Tableau, to design a chart. So in data journalism, we often hear the fact that we're like living in the golden age of charts because basically they are everywhere. Like more and more people are incorporating them in their workload and toolkit. Like, for example, what we've seen during the COVID-19 coverage, data visualization and maps have come to play a crucial role in the response given by the media, the government, civil society. And that's why I decided to kick off with this dashboard that you probably already know very well, the very good Johns Hopkins live display of coronavirus cases. And as we've seen in this example, the reason why visual storytelling has become so widespread is because it can be actually like very useful. When well designed, visualization can help to inform our public better about very critical topics. So they allow us to identify patterns and trends in the data, and they're a powerful tool to make information both more understandable, in depth, but even just more compelling on a pure visual level. But it has to be clear and accurate in first place, because as well as like having the power to inform, they also have the power to leave a lasting impression on audiences. They're associated with science and reason, and studies have shown how the human brain is much more inclined to believe information presented visually, especially when supported by data and numbers, because the assumption is that numbers and data make information more objective, more precise, and that's why charts become very seductive, very persuasive, and they're definitely harder to fact check. So as creators of data visualization, we must be extra careful, as I was saying, with what we produce and with the fact that there are a number of things that could go wrong, from charts made with the clear intent to mislead the public, up to bad charts because of the poor choices or just sloppiness of the designer. There are a whole range of things that could go wrong in chart designing. But I would say that there are three main areas. So the first one is about the source. So displaying the wrong information or just displaying too little or too much information in order to present a certain interpretation of the data. The second area is about how the chart is designed. So even if the chart displays the right information, it can still be misleading due to poor design or poor labeling, for example. And then even nicely designed charts might still be misleading if you don't put attention when reading the charts. So all of this basically revolves around the fact that all data visualization, statistical graphs, maps are not as objective and precise as they may seem. Like they're always the result of a number of choices that we have to make, and every choice that you will make will compromise the data in some way and prioritize some elements compared to other. So again, one of the most common mistakes that we see around is to display too little or too much information to present a certain interpretation of the data that we want to push. And this is a specific data misinformation tactic called cherry picking, like removing part of the data to show a specific narrative. And it's a very effective way to deceive people, because basically you choose the numbers carefully according to the point that you want to make, and then discard whatever may refuse it. So you could frequently encounter graphs like this one on the left in the field of climate change deniers. Here they use data to argue that global warming had stopped and then the world is now cooling. But there's something wrong with it. It certainly looks like temperatures are on the way down, doesn't it? But the chart has one big problem. Like in 1998 was an unusually warm year, that's true. But climate change is a long-term effect. In order to see global warming, you need to look at temperature trends over decades, not over single years. This means that if you start your graph from this particularly hot year, it will seem that things are cooling down. But really, the world is still steadily warming, and you've just cherry-picked some data to make it seem otherwise. The graph on the right shows what's really going on. So again, no chart ever captures reality in all its richness. But however, a chart can be made worse or better depending on its ability to strike a balance between oversimplifying the reality, choosing just too little data, and obscuring it with too much detail when you choose too much to display too much data. And in terms of like chart designing, there are so many things that could go wrong. Like even the process behind the creation of a very simple bar chart, it's not as easy as it might seem, because like, as we said, all charts and maps are never a perfect reflection of reality. They're always like a projection and the result of a series of choices. So they're not just like simple and pretty illustration that can be made and understood easily and intuitively. But we always say that like we should start treating them as if they were something more complex, something like a text, for example, as the famous data visualization expert Alberto Cairo always says, like a text with its grammar, its semantics, its arguments that you need to read in order to interpret it correctly. So we have to be very careful that we don't produce like visual distortion and we don't make bad design decisions or choose convenient angles to prove or exaggerate our point. This kind of map was largely used during the reporting about COVID-19 and the rising cases around the world. And this example in particular was published on Bloomberg to map where coronavirus was spreading more quickly in the US. But the map is highly misleading, as we were saying in the previous presentation as well, because the map does not show population density, which results in a huge misrepresentation of scale. The use of a choropath map is wrong here, while a density or even like a dot density map would show more accurately where most of the cases were concentrated. And also the use of color. The use of color is very wrong here because red is like the data viz equivalent of shouting and is highly emotionally charged. So also the color shades are too similar to distinguish. And we have seen the same mistake made on several publications, and we have many examples, like in the BBC map on the left that show the spread of the virus in China, or in the one by the Canadian broadcaster Global News. Again, the maps are showing totals, like absolute values, instead of being normalized for population by showing cases per capita. In this other example, similar example that was created by the cartographer Kenneth Field, the map at left represents a flowed example as compared to the version at right, which correctly utilizes rates as opposed to totals and without sensationalist color choices. Then he went on and he created an even better version of the map, either a dot density map on the left or a map with graduated symbols, where a range of values are snapped to a set of symbols of a specific size. In this way, you can clearly see where the highest number of cases is concentrating without distorting reality. And then the design of a graphic, like its scales and encodings, should depend always on the nature of the data. This is a very famous case, an example of a 2011 map showing basically flight routes with like red lines encircling the globe. And the map here showed global air traffic routes and traveled for the entirety of 2011. But then the map was then picked up and shared on social media completely out of context. So it was shared around the world saying that first that this was how the virus would spread, so like a prediction, and then saying how it had spread already. So this ties into basically the last area I wanted to highlight, which is the fact that charts can deceive us because we don't put too much attention into reading them before sharing them on social media, or because we might be influenced by our opinion and what we see in them, what we want to believe. So as an example of this, during Australia's extreme bushfire season at the beginning of 2020, Rihanna tweeted a highly misleading picture of the country to her millions of followers. The picture was mistaken for a satellite photograph, showing basically the country being on fire, and was like widely shared on social media everywhere around the world. This picture was in fact a 3D art representation made using hotspot data from 31 days of fires. So the artistic representation of the fires was never intended to be an accurate representation of data. Part of the problem with the map was not the map itself, but was the misinterpretation of these maps due to the fact that people didn't put too much attention to where it came from, who generated it, why they generated it, what data they used, and so on. And the same thing happened with the map on the right. That's My Fire Watch map, an initiative of the Western Australian government that had the perfect combination of bad design, poor design choices, and widespread misinterpretation when it was shared online. So the design of the map had a number of issues. First of all, rather than wildfires, the flame icons represent sources of heat on the Australian country. They're above a certain temperature. So many of them were not even fires. So it was a very sensationalistic choice in its use, and the flame symbols that imply a much larger area that was burning. And the map with Australia overlapping Europe, of course, is like very wrong and intended to mislead. There's a very famous book, How to Lie with Maps, by Marc Monnier, that says explicitly that all maps lie. And because cartographers have always been presented with the impossible dilemma of projecting a three-dimensional object, which is the Earth, onto a two-dimensional surface, which is the map. So the results are always distortions of the globe, like an imperfect model of reality. So in this case, for example, the use of the Mercator projections, which was created in the 16th centuries, but it's still like widely used today by almost all online map providers, including like Google Maps. So this projection distorts land masses depending on their position relative to the equator. So in order not to fall into any of these mistakes, there is some work that needs to be done before the visualization. And the visual representation of the data is just the last step as part of a long process that starts with the collection of the data. That could be, of course, from like an existing data set, creating new ones, like, for example, scraping new data, scraping social media data, as well as like combining existing data set and creating new ones. Then after the collection, it goes on the cleaning and turning your data into the right format and drawing some analysis based on it. So only at this stage, you start thinking how you want to visualize your data. I think I missed one slide. Okay. So the cleaning is the essential phase because it is where you will check your data and you will make sure that it's reliable and you prepare it for the analysis. Basically, like many of the mistakes in chart designing are actually made in this phase. And data journalists know that cleaning can also be like the most time-consuming phase, as this survey from 2016 shows. Especially when the data is collected online or when you collect your own data, for example, you will probably receive a file with many missing values at bad formatting, and you have to clean those in order to be sure that then the analysis will be accurate. So this is an example of a sample of a messy data set that I found online, where you want to look for example, values in wrong format, like date, for example. If you want to analyze trends over time, you have to be sure that the dates are all in the same format, and then they are all recognized by the program that you will use to visualize the data as dates and not a string. Same thing with numbers. If you want to operate some calculation with the numbers, you have to be sure that they're all in the same format and they're all recognized as numbers. Then you can have missing values, empty cells, several data in a cell, which is often, again, caused by bad formatting. You can have misspellings, like the ones in the column movie title. You can have some values that may contain bad characters or like null values. You can have rows that should actually be columns or vice versa. So there are a number of things that could be needed to be cleaned. But if you check all of these things, then you will make sure that when you go on with the analysis, the visualization and the visualization phase, your numbers won't be compromised. And how we actually clean the data depends on the skills and the resources that you have at your disposal. You could use some coding programs like Python or R to handle the data, which are definitely quicker, but you can also use some advanced techniques on programs like OpenRefine or Tabula. But even just a good old spreadsheet will do the work of transforming your raw data into a normalized format that you can then filter and easily perform analysis on. The Google spreadsheet has recently introduced a new function where it will basically like suggest you a number of operations to do in order to clean the data set. So that might be a useful place to start. So after preparing and cleaning the data in a nice clean format, we can start thinking about the best way to visualize the data based on some of the analysis that we have made. So first, we must define what we want to highlight with that visualization. Then this will determine the visual encoding that I choose. So I have to pick out one main point that I want to communicate and then focus the visualization on that. So when it comes to choosing the right charts, the Financial Times has created this fantastic resource to help organizations to identify the most effective visualization. So you can ask yourself, what exactly do I want to visualize? Is it change over time, for example? Then a line chart or a bar chart could work well. A bar chart could also be helpful if you want to visualize the ranking. So the worst, the best, the top 5, etc. Or a scatter plot or a heat map if you want to represent correlation. So the relationship between two or more variables. So once you have decided which chart better represents what I want to communicate, I need to consider the whole grammar and vocabulary made of symbols, like the lines, the circles, the bars, and then the visual encodings, if I am representing length, positions, color, and so on, and the text, the annotation layer. This is an example shared by the data visualization expert Alberto Cairo again in his book, How Charts Lie, where he shows a whole range of elements that we need to consider when we approach data visualization design. So this specific one is a scatter plot representing how the results of special elections have changed in the US after the inauguration day for both parties in 2017. It doesn't really matter what the charts represent in this case, but it's a good example because it has all the elements that make a good chart. So first of all, the annotation layer, which is part of the visualization itself. And it's something that chart designers tend to forget. So we need to include a very good title, a very simple title, but I also have to give the reader some information about what they need to read in that chart. I always recommend to use more like descriptive titles instead of just, telling what the data is. And then we can use an introduction or a description that again gives the reader all the information to decodify my graph. And then the source and caption is also very important. Always be cautious about graphs that don't have the source within their own space. And then the measurements, the units, the scales, the legends, because charts must tell you exactly what is being measured and how. And then a legend explaining the method of visual encoding. So what does the color stand for? What does the dimension stand for? So sometimes you also want to add some annotations to the chart to emphasize the main takeaways and highlight some relevant information, like in point 4 in this chart. So there are many tools for making visualizations, from custom tools like Flourish, Data Wrapper, Tableau, where you basically don't need any programming skill at all, but they have some restrictions in how you can customize your chart, and also in the fact that if you use their free versions, when you go and embed the charts within your web page, you will always have a logo from the program within the graph. So there are also many scripts and libraries to make more advanced and interactive visualizations using JavaScript, for example, or R or Python. So Tableau is perhaps the most popular visualization tool, which supports a wide variety of charts, of graphs, of maps, and other graphics. It is a completely free tool, and the charts that you make with it can be easily embedded within your web page. Again, I don't love to use the free version because of the big footer that it comes with, but it's definitely a great place to start with. So I'm going to go through some of the individual steps involving the whole workflow process, including how to upload your data, how to create interactive and compelling visualization. You can also do some cleaning and analysis directly on the web page. So I'm going to share the application that you have to download on your computer. There we go. So you can download it on your computer, and then you have to put your login details in order to be able to use it. So on the left, you have different ways that you can use to upload your data. So you have Microsoft Excel, text file, JSON file, PDF file. You can also connect it to a Google spreadsheet. You just need to be sure that you save the sharing functions as it open, because otherwise the Tableau wouldn't open it. Then I'm gonna use the Excel file here, and I'm gonna take this World Bank CO2 CSV that I have on my laptop. You can just browse within your browser to find the file that you're looking for. So once I open, it might take a few seconds to upload. And then here on the space on the left, you basically have all the sheets that are part of your data set. So what you need to do is very simple. You just need to choose one of the sheets and basically drag it here in the center. Perfect, there is some error going on. Let's try again. Okay, I think my computer is overloaded at the moment. Let me just try and close Tableau and then reopen it again. In the meantime, if you have questions, we can open it up to questions.
Yeah, and if you want, if you already have Tableau downloaded, folks, you can also open Tableau and follow along.
Yeah,
with what
absolutely. It actually never happened to me before, so hopefully I'm just going to open it up again and it will work fine. Before sharing my screen again, I'll just see if it works now. Again, you can use like any kind of data, but in order to be sure that the program recognizes the way your data is structured, you have to be sure that the data is prepared and cleaned, as I was showing before. So I think it's working now. Let me share the program again. So as you can see here, after I dragged the data cleaned sheet in the main space, this will give me a preview of the data that are contained. So we have different columns. We have the columns with the countries that are represented in this data set. So the country code and the country name and the region. Then we have the year, because this data set will show me throughout the year the number of CO2 emissions by country. And then we have the CO2 emission column, and we have the CO2 emission values per capita. So here I can play around with the data. I can, for example, decide that I want to give a different order to the data set. I can change the names of the columns. These symbols, these icons at the top are also very important, because this tells me the data format that is recognized by Tableau. So this one is text, this one is number, and this one is location. So in order to make sure that the program will visualize the data correctly, I have to change this if the format is not right. So I can choose here whether I want a string, so a text, or a date and time, number, etc. So once I make sure that the data is well uploaded, I go on sheet 1 here at the bottom on the left. And once I click here, I will see that all my columns are represented again on the left. And in order to visualize the columns, it's very easy. I can just basically like pick up one of the columns and drag them here. So I drag them just in the center space, and then I can drag the other one and see how Tableau is going to recognize it. So this one, for example, is showing me for the whole world, the trend of CO2, how they changed over time. But maybe I want to see this country by country. So I'm going to pick the country names column here, and I'm going to drag it here. So this will add any single country as part of the visualization. So Tableau basically choose the best way of visualizing the data. I can also decide to change way of visualizing it here at the top right. But in this case, Tableau decided to visualize the data that I requested with the multiple line charts. So what I'm going to do is to trying to make this chart a bit easier to read. So I'm going to drag the country name onto color. So this is giving a very complicated and too many color mixed. So I might try to use the CO2 per capita instead. So this will show from the lighter to the darkest color, which countries have been emitting more CO2 throughout the years. So I'm going to change the colors, and I'm going to use a different palette to make this difference even more evident. There you go. So now I want to see I want to analyze this data from a different perspective. So I'm going to open a different sheet here, and I'm going to drag the country name here, and I'm going to get the CO2 per capita, because I want to see which countries are the most polluted in the word pro capita. So I'm going to drag this into my columns. And again, Tableau decided that a bar chart is the best way to visualize this. I can change the order, and this will show me very quickly which countries are the most polluted country. But I want to try and visualize this in a different way. So I'm going to choose a map, and a map with some bubbles. So each bubble represents one of the country where the data is present in my data set. And then basically it resizes the bubbles based on how much CO2 the countries are emitting in relation to their population sizes. So again, I want to do some manual editing, and I want to add the CO2 per capita on color to see the difference in a clearer way. So I'm gonna choose the same palette as before. I'm gonna use this one. And as you can see, I can also resize the bubbles to see this more clearly. So again, Qatar as being the bigger polluter per capita. But I can also play around with the different bubbles and see which ones are the other countries that are have been the biggest polluter. So something else that I think it's very interesting is that you can create a dashboard, and basically you can connect the different charts and different visualizations that you have. So I'm going to click here on new dashboard, and what you find is the two sheet on the left that you have created. So I'm going to drag again this one here that will appear here, and then this other one at the bottom. So basically this is how it's going to appear on your web page. It is already mobile responsive, of course, but you can decide to change the size according to the space that you have available. And then something that you might want to do is to connect the two charts in order to use this one as a filter for this other one. So what you need to do is to click on this little icon on the top in order to link the two visualizations. So here, for example, when I click on Qatar, this will filter the multiple line charts at the bottom and will show me the trend over time. So I can see that clearly that even though it's the most polluted country, at the same time, the trends are going down. whilst for other countries, the trend might going up. So like, for example, for this other country, Trinidad had an increasing trend in terms of CO2 emissions. Something else that is very important is to add an headline. So I'm going to click here and I'm going to choose a title. And I can decide to introduce a description. I can add some annotation layer. I can decide to leave the legend. I can decide to remove it. Basically, this is where I customize the graph exactly how I want it, and then embed it on my web page. So once I'm happy with it, I'm going to remove this title. Once I'm happy with it, I need to go on File and then Save to Tableau Public. In order to do this, I have to have some login details, and then this will open up a web page where basically you will have all the links, like embedded links, iframes that you need in order to include this graph within your web page. So it's very, very easy to use. The things that you can do are very, very numerous. When it comes to chart designing, really, like, only the sky is the limit. But yeah, of course, always be aware that you have to respect the rules and the guidelines that we have discussed before, but it always depends on the data that you're trying to visualize. So I know that was a very, very brief introduction. There are so many things that you can do with it, but thank you so much for the attention.